Astronomers have long wondered whether a mysterious ninth planet might lurk in the far reaches of our solar system. In 2016, researchers at Caltech, Konstantin Batygin and Mike Brown, proposed a Planet 9 based on the curious orbits of icy bodies beyond Neptune. These trans-Neptunian objects, TNOs, exhibit clustered paths that seem to point toward an unseen massive object. If real, Planet 9 would be a giant super-Earth, roughly 5 to 10 times Earth's mass, following a highly elongated orbit 20 to 30 times farther from the Sun than Neptune. In other words, it might orbit some 500 to 1,000 plus astronomical units AU away, so distant that one full orbit could take 10,000 to 20,000 years. This hidden world remains hypothetical, nobody's yet seen it, but if it exists, it would help explain many oddities in the outer solar system and make our planetary family more like the norm seen around other stars. The idea of a hidden planet isn't new. In the early 20th century, astronomer Percival Lowell searched for a planet X beyond Neptune to explain slight anomalies in Uranus's orbit. This quest accidentally led to the discovery of Pluto in 1930, long thought to be the ninth planet. However, Pluto turned out to be far too small, only 0.2% Earth's mass to influence the big outer bodies. In fact, the 2016 redefinition of planet downgraded Pluto to a dwarf planet. That left our solar system officially with 8 planets, until Batygin and Brown's 2016 hypothesis reclaimed the title Planet 9 for a new hidden world. In short, there has been a historical vacancy in the 9th slot, and today's Planet 9 revives that century-old mystery under a modern scientific lens. The Kuiper belt is a vast ring of icy worlds like Pluto, Sedna, and others orbiting beyond Neptune's 30 AU distance. Beginning in the 1990s, astronomers cataloged thousands of Kuiper belt objects, KBOs, and noticed something odd. Many of the most distant objects have orbits that are mysteriously aligned or tilted. For example, Sedna and a few similar bodies have very elongated orbits with perihelia, closest approach to the Sun, far beyond Neptune's orbit. In 2016, Batygin and Brown reported that 6 such extreme KBOs have perihelia clustered in space rather than randomly distributed. They argued this clustering could be caused by a massive unseen planet gravitationally shepherding them. In other words, the orbits of these distant icy bodies suggest the pull of a giant planet out of sight. Batygin and Brown used computer simulations to map out what kind of planet could produce the observed alignments. They found a Neptune-sized world could do it, but with an orbit hundreds of times farther from the Sun. Based on the simulations and dynamics, they estimated Planet 9 would be roughly 5 to 10 times the mass of Earth, making it a super-Earth, or mini-Neptune. Its orbit would be highly eccentric, maybe as close as 200 to 300 AU at perihelion, and as far as 1,000 plus AU at aphelion. For context, Neptune orbits at 30 AU. This extreme orbit is inclined relative to the other planets. With those parameters, Planet 9's orbital period would be on the order of 10,000 to 20,000 years. Put simply, Planet 9, if real, would be a cold, giant world in the outer abyss, never seen yet, but big enough to tug on other objects. Space.com notes its evidence points to a giant planet with the mass of 10 Earths, orbiting about 20 times farther from the Sun than Neptune. That matches the Caltech prediction. Batygin and Brown also nicknamed it Planet 9, because Pluto had lost that slot. If we found Planet 9, it would be our first true super-Earth, a type of planet commonly seen around other stars but absent in our own system. Astronomical surveys of exoplanets show that worlds a few times the size of Earth, larger than Earth, smaller than Neptune, are very common. Our solar system currently has no such middleweights. A massive Planet 9 would make us more normal in that sense. What would Planet 9 be like? We don't know. It's far from the Sun, so it would be extremely cold, likely 200 degrees or colder, and faint. It might be an ice giant like Uranus, Neptune, or a giant rocky core. It could have a thick hydrogen-helium atmosphere if it formed with enough gas. Its surface, if it has a surface, would be tens of billions of times dimmer than sunlight on Earth. Some models suggest it could have methane clouds, making it appear bluish in the infrared. But these details remain guesses until we detect it. If Planet 9 exists, it neatly explains several strange features of the outer solar system. NASA summarizes that it could help account for tilted orbits. Many distant KBOs have orbital planes tilted by 20 degrees relative to the main planets. Planet 9's gravity could induce this common tilt. Orbital clustering. The perihelia of those extreme objects all point in roughly the same direction. A distant planet can shepherd them into a common alignment. Inclined and perpendicular orbits. Some far-out bodies have orbits tilted nearly perpendicular to the solar plane. Simulations show Planet 9 can scatter objects into such odd orbits. Retrograde objects. A few objects circle the Sun backward, retrograde. Planet 9's perturbations could flip some orbits. Neptune crossers. There are long-lived KBOs whose orbits cross Neptune's path but remain stable. Planet 9 can keep those orbits intact for billions of years. In essence, a distant planet helps explain why we see these synchronized patterns. Without it, we'd have to accept that numerous Kuiper belt objects just happen to wander on aligned, tilted paths by chance. The Planet 9 model provides a tidy, dynamical explanation for all these phenomena at once. Not all scientists are convinced. Some recent surveys cast doubt on the original clustering signal. For example, the Outer Solar System Origin Survey, OSSOS, detected hundreds of distant objects and found their orbits point in many directions, suggesting the earlier alignment may have been a statistical fluke. Mathematical models also show Neptune's migration in the early solar system could naturally produce a lot of the observed eccentric orbits in the Kuiper belt, leaving only a few truly extreme cases that might still hint at something else. Other teams have even proposed non-planetary explanations. A 2023 study suggested a modified law of gravity, so-called M-MOND, could reproduce the orbital data of distant objects without any new planet. In their simulations, the gravitational pull behaves oddly in the outer solar system, aligning orbits just as observed, a striking fit according to the researchers. However, this is controversial and does not definitively rule out a planet. Crucially, NASA emphasizes that Planet 9 remains hypothetical. It has not been observed directly. The clues are indirect, and scientists debate whether a planet is really needed. Some researchers argue that the clustering could stem from subtle observational biases or just be a random coincidence of where and when we look. In fact, NASA notes, another possibility is that Planet 9 does not exist at all, with the unusual orbits explained by chance. How do we find Planet 9 if it exists? It's extremely faint and moves very slowly, so it's like looking for a dark needle in a cosmic haystack. Astronomers have combed through existing survey data, Hubble, Subaru, Pan-STARRS, WISE, infrared sky maps, etc., for any sign, so far without success. A citizen science project, Backyard World's Planet 9, invites the public to examine NASA's WISE infrared images for any moving object that might be Planet 9. A promising avenue is the upcoming Vera C. Rubin Observatory, formerly LSST, in Chile, slated to begin full operations in 2025. Over a 10-year sky survey will repeatedly image the entire southern sky with an ultra-wide camera. Rubin is expected to discover thousands of new distant objects each year. Crucially, if many more Kuiper belt objects are found and they do not show systematic orbital alignment, that would cast serious doubt on Planet 9. Conversely, if a pattern persists or an object fitting the criteria is found, Rubin could finally detect the planet or pin down where to look. Recently, 2025, astronomers even scoured old infrared data from IRAS and Akari satellites and identified a few candidate moving objects. One tantalizing candidate showed up in both datasets. However, Mike Brown cautions that its orbit is so inclined and retrograde that it is 100% not Planet 9. In other words, even if a moving object is real, it may not be the one causing the KBO alignments. At least, this search shows the difficulty. Many false positives, noise, asteroids, transient events, must be ruled out. Planet 9 remains one of the most intriguing mysteries in planetary science. If it's out there, the next few years may be decisive. Rubin Observatory and other surveys might turn up the telltale slow wanderer, or else show that the hypothesized planet isn't needed to explain what we see. As Dr. Batijan himself said, until Planet 9 is caught on camera, it does not count as being real. All we have now is an echo. Yet co-discoverer Mike Brown argues it's a question of when, not if, we find it. Because otherwise, the solar system makes no sense without it. For audiences around the world, Planet 9 is a captivating story. It challenges our understanding of the solar system, blends detective work with cutting-edge technology, and reminds us that even our cosmic backyard may hold huge surprises. The hunt will continue, and with new telescopes and clever analyses, we may soon know whether a hidden giant truly resides at the solar system's edge.